Hey, what's up, Spiceheads, and thank you for joining us for a very cool video meetup today. So today's show is a little bit different. We've actually got 4 vendors all come together who've agreed to set aside their individual sales pitches for now, and they're really just here to spread the truth about flash storage and what it's about. So now we've all heard about flash arrays by now, SSDs. We've heard a lot of marketing promises. We've also heard a lot of wild rumors, frankly, from other IT pros we know. And today, that's what we're here to do, is to bust through those myths and to find out which of these ones are fact and which ones are fiction. So before we get into that, and I wanted to cover a few housekeeping items. For those of you who haven't done a webinar with us before, you're in the platform, you've got it open right now. I just wanted to point out a few widgets that you might want to be aware of. So on your console, you should see a video widget where you will see all of our lovely faces. Everyone want to give a wave to the camera? Say hi, everyone. And the window, and it'll also contain a slide that actually has everyone's contact information as well as where they come from. So if you have more questions for the folks, either after the fact, you can certainly reach out to them through Twitter, or if you can't catch them in the conversation itself. There's also another couple of widgets you might want to be interested in. On the bottom of your console, there is a brown widget. It allows you to chat with other attendees. And you also have a red Q&A widget for when you want to shoot questions. We've got a list of flash myths that we've been coming up with, that we've collected from the community, but we also want to definitely pull plenty from you guys as they're coming in. So we also have a Twitter widget. That's going to be a new thing that we're doing this trip around. So it's going to show you all the people that are tweeting about this event using the hashtag #Mythbusters. And you can also use the widget to tweet your own comments about the show for others to see. It's automatically going to add that hashtag for you. And we have prizes today, right? Yeah, our prize today is a $50 Amazon gift card and a yoga tablet. So good luck to all of you guys. We'll be announcing the winners at the end of this show. So without further ado, I want to start off today by introducing our Knights of the Round Table, so to speak, for today. These are some of the best minds in the flash storage industry that have all come together from various different companies. Thank you guys all for joining us today. Batting first, I want everyone to say hi to Jeramiah Dooley. Jeremiah, do you want to say hi to everyone and introduce yourself?
Sure. Hey, everybody. Glad to be here. My name is Jeramiah Dooley. I'm one of the cloud architects over here at SolidFire, and looking forward to the questions and looking forward to getting to hang out with all the guys on the panel here. Okay, and Kid, do you want to give us a little bit about your background, how long you worked in IT, and how long you've been at SolidFire? Sure, I've been at SolidFire just about a year now. I've been in IT, 17 years at this point, a little bit all over the place. Done a bunch of healthcare, spent a lot of time on the service provider side of things, building out infrastructure and particularly VMware-based public clouds. Spent a few years over at VCE talking about converged infrastructure, and have been here on the SolidFire side for about the last year.
All right. Well, thanks so much for joining us, Jeremiah.
Of course. Glad to be here.
Cool. Next up, I'd like everyone to say hi to Devin Hamilton. Devin, can you say hi to everyone and introduce yourself?
Sure. Good morning, everybody. This is Devin Hamilton. I'm the Director of Storage Architects at Nimble Storage. I've been in data storage for approximately 23 years. Nimble was startup number 6 for me. I've been working in customer advocacy for most of my roles at a lot of different companies, and have been a volunteer within the community for a long time. I'm really happy to be part of the Spiceworks community and really looking forward to the discussion today. I've been at Nimble for about, coming up on 5 years. I was the first systems engineer there. Okay,
Devin, where are you calling us today from?
I'm actually calling out of Seattle, Washington, which is my hometown, born and raised.
Very cool. Well, welcome again. Next, I'd like everyone to say hi and give a warm welcome to Sam Marasini from EMC. Sam, do you want to say hi to everyone?
Hello, everyone, and good morning, good evening, good afternoon, wherever you might be. Sam Marasini. I have, for the last 18 months, been EMC's Flash Strategy Director. Been with the EMC about 15 years, and we'll say 20 plus in the IT industry, if that's good.
Okay. And Sam, where are you calling us today from?
Today I'm calling from Columbus, Ohio, just a stone's throw away from my hometown of Pittsburgh.
All right. Well, cool. Thanks for joining us. And batting cleanup, last but certainly not least, I'd like everyone to please give a warm welcome to Vaughn Stewart.
Hey, everyone. Thanks for joining us on this call. I think we've got a fantastic lineup of questions and information to share with you. I'm pleased to be joined by my peers within the industry. Just a little bit of background. I'm Vaughn Stewart. I've been at Pure Storage as their chief evangelist for just a little over a year and a half. Spent the prior 13 years at NetApp, where the last 7 of that was leading a lot of strategies around the direction and integrations with VMware and other cloud partners. Very excited to talk to you about Flash today, so Justin, take it away.
All right. Well, thanks, guys. Once again, be sure to get the questions in. You can either ask them through the chat, and if you want to ask them through Twitter, we'll probably try to pull some from there too as well. We'll kind of see how it goes. So last week, I did post a thread in the community that was asking for Flash myths to ask on today's show. I tried to be democratic by letting all of you Spice heads decide the winner by determining through the Spice ups. But in true Spice head fashion, the winners ended up being the smart-ass joke post that got all the Spice ups. So thanks, everyone. That's what happens when you let the crowd decide. But I will have to say that some of them were pretty hilarious, so I definitely want to read a few. We're going to be announcing the real winners later on. But for any of you guys, for all of you guys, if you ever come to Austin for Spice World to be on the air, I'll definitely take you out for beers. So the first, one of the first myths that we got was from Rob T, who says HTML5 storage is going to be better. We also got one from the randomist who said, is it true that Flash storage will be the savior of the universe? Like the Queen song, Flash. Oh!
Awesome.
And then Digital Man says, I don't want to dance around the obvious. Flash is unreliable, and if you don't believe that, you're a maniac, oh love. So, nice. Good joke. I didn't know we had such comedians in the Spicehead community, but, if I
There were no token ring questions. I'm surprised.
What did you say, Sam?
There were no token ring questions. I expected that.
So we'll definitely announce the rest of the winners later on. So without further ado, wanted to start going down some of these myths that we're getting. This first one, I think is just a little bit of confusion that some folks have. And the first myth is that solid-state disk or SSD and Flash are basically the same thing. Devin, what do you think? Is that fair and accurate?
Sure. I mean, I think in the minds of most folks that are looking at SSD and just thinking in terms of the marketing material around Flash, they kind of hold them synonymous. But ultimately, I mean, Flash and SSD are two completely different things from the standpoint of potential implementation. Folks are using Flash on hard mount within cards, within embedded systems, and then, of course, SSD is just one particular use case where Flash is inserted. I think that when we look at what is prevalent in the space today, people are really used to that 2.5-inch drive segment form factor and the storage array, and I think all of us here kind of represent a portion of that with offerings that we represent. But realistically, Flash is ever evolving. So while we see that in SSD and that being a prevalent package today, even just kind of taking a cue from a company like Apple in the end user space, already hard mounting that stuff on boards and really moving away from that package of a solid-state disk. But I think you're going to see those for some time to come.
Great. And Vaughn, what do you think about that?
Yeah, so I think Devin made some really good points. I think Flash, by and large, for most, resonates with an SSD. But understand that SSD is really a packaging designed for the drop-in of Flash or NAND Flash in the place of a disk form factor. So Flash can drop in as a direct replacement for disk. It needs these requirements and capabilities. I also think that model is one that's been pervasive in the architecture of a number of our systems. I think as you look forward, the system integrators within the storage space will start to move away from that form factor and focus a little bit more on density. But let's be clear, I think what we're talking about when we say Flash is NAND Flash. There are other forms of Flash, just like there are other forms of networking besides Ethernet. NAND Flash will be the pervasive form of Flash that we will be discussing in market here for storage for probably the next decade.
Okay. And Jeremiah and Sam, either of you guys have anything to add?
I would add that Vaughn's absolutely right. It's the NAND chips that we're really talking about here, right? It's the NAND chips that are in absolutely every device that we're using today. And, we can really thank Steve Jobs for commoditizing Flash, bringing the cost down and allowing us to get to the point where it makes sense in the data center. Absolutely. That's really what it is. It's NAND.
Yeah, and I would say that don't discount the usefulness of the packaging in the SSD form factor. I mean, part of it is that becomes the simplification, that becomes the way that we drive the consumption model of the NAND Flash on the back end. So it's not that one is more important or less important than the other. One is just a vehicle that we use to consume the NAND Flash that sits on the back end. And I think that the form factor may change, The interconnect may change, but that idea of taking the NAND and putting it into something that's easily consumable, I think from a manufacturing standpoint, from a customer consumption standpoint, all of those things are and will remain important. So both of them important, but not necessarily the same thing.
Okay. And our next myth is one that I definitely feel like the tide is definitely shifting, but it was definitely an impediment for some folks early on. And this myth is that flash storage is unreliable because it wears out over time. Vaughn, do you want to take first stab at that one?
Sure. So the myth is true and false at the same time, and I'm sorry for such a clear statement to open with. Flash does have a finite number of charges that it can take, and writing the flash is the most expensive or taxing charge. So from that perspective, yes, you can wear the flash out, but there's a little bit more that's going on inside of flash in terms of how it's programmed and erased that's different than disk storage. There's this concept of being able to write at a very micro level, but having to erase at the macro level. And that procedure of erasing flash means you have to move data around. And so you have this effect called write amplification. And so basically, when vendors are rating their SSDs for lifespan, they have to factor in write amplification. And that write amplification rating across the industry is 8.6. And that's basically saying if you take a flash SSD, stick it in the place of a hard drive, you're treating it in the worst possible manner, and as such, here's your life expectancy based on reads and writes. I think all of us and all of our platforms treat flash very differently than that use case, and we're able to extend the life of this medium through methods like data reduction technologies, which preserves writes, through means of where we optimize our garbage collection, or through means of excess capacity, hidden reserves, if you will, called Auburn provisioning. Those technologies come together in some form or fashion in all of our systems to make flash much more reliable. I'm going to leave it at that so the rest can comment.
Jeremiah, what are your thoughts on that?
I think Vaughn hit it. I would say that probably, thinking through our 4 companies, there's probably none of us who actually write to flash, right? I mean, none of us are writing, taking customer I/O and putting those writes directly to flash. There's always a prep process, and that process, contributes to the data protection. It contributes to failure modes and failure models. It contributes to how we implement data services. But the end goal of that is every time we touch the SSD, it's a finite resource. And so the better we can prep that I/O, the better we can prep those individual blocks in order to be laid down in the right way, the more we extend the life of that disk. So if from a myth standpoint, if you take the idea that here's how a storage array treats this spinning disk, if we treated an SSD the same way, it would literally melt. Like it's not feasible from a technology standpoint nor from an economic standpoint. So many of the data services that Vaughn talked about, we put in to extend or to change the economics of it. But the reality on the technical back end is that we have to overcome that write amplification problem, and that's really the way that we do it.
Sam and Devin, do either of you guys have anything to add?
I do. I think my perspective on this is a little bit different because a lot of it is fueled from when I first started at Nimble. Our philosophy at the time was that about 5 years ago, we were looking at flash that really did truly have a reliability problem at that time. And I think what the consumer is really coming around to recognize now is that data organization matters. And ultimately, the way in which you use flash, there are bad ways and there are good ways. And wherein there are some early solutions that have done kind of okay in the market where simply flash was a replacement for disk. Obviously, they didn't have anywhere near the reliability potential of something that organizes data and lays it out in a way that flash can deal with well. I think when we look out across the broad spectrum of customers that we have, there's an awareness of almost a foregone conclusion that flash for the purposes of write caching or being an endpoint of storage residency carries more risk with it than using flash for reads. And really that's kind of the fundamental basis of our architecture, obviously within Castle. So the notion that we have is that if you organize the data carefully, you can place the data there during metered write events with sequentiality that would completely eliminate write amplification and thus boost the lifespan of flash. Our anticipation today, based on the numbers that we see for data coming in, is that drives that are rated at 5 years will actually see the maximum natural organic degradation of about 7 years. So again, the use case matters. Data organization really has a lot to do with the longevity of that asset.
And I think everybody's spot on. Maybe the only thing I would add, if you step back a second, it's the NAND chip that's inside the solid-state disk that can easily be inserted into an enterprise storage array. If you treat it like you used to treat spinning disk, you're doing it the wrong way, because flash is fundamentally different in architecture and in what it needs to do. Write amplification is one of the things that need to be taken into account. But there are other things that you throw out, right? There's no seek time. There's no rotational delay. This is completely different. And depending on your storage architecture, that's how you extend the life of that flash so that it really becomes a moot point. And I think we all agree that we're past that. This is absolutely a myth, and different architectures address it differently, but I think it's addressed in the industry.
Yeah,
I would say that within.
Go
ahead, Ron. I'm sorry.
Let me add one point to simplify this for the audience. I opened my response to this question talking about write amplification, basically this element that I don't think is widely understood, and how it impacts the longevity of flash. When you look at the data reduction technologies that are in all of our platforms, you may believe that this is to help reduce the cost so that you can adopt these platforms, and that is true. But from a flash longevity perspective, when you look at technologies like data deduplication, what that is saying is that every piece of data, every bit of data, you should say, stored on flash is globally unique, right? So I'm not writing redundant data. And every data, if I have technology like compression, is going to be stored in a denser format, so I'm writing less data. Those two simple examples, by no stretch of the imagination, explain everything. But if you can understand that you can preserve your writes and write less capacity, I can extend the longevity of this flash and turn, the write amplification numbers, if they're 8.6 for sticking flash in your laptop, to less than 1 on an enterprise storage array, I can have an 8-fold increase in the longevity of this medium. And I think across the industry, we're all achieving similar results in terms of longevity.
Well, and I would say, the ultimate proof that this myth is completely busted is that the majority of the vendors out there, I'm going to replace every drive that ever gets to any point of anywhere whatsoever for the lifespan of the array. Like we can talk about the technical reasons behind it and how we've solved it and those sorts of things, but from a customer perspective, if ever inside a SolidFire array you ever get to the point where any drive exhibits any sort of wear that would impede its ability to be used, we're going to replace it. And we're certainly not the only company doing that. So technically we've solved the problem. From a business standpoint, we can just take this one completely off the table and let customers worry about how they're using it, not the mechanics underneath.
Busted.
Indeed.
Busted.
Myth busted. I wanted to take some time to check in. We've got a lot of questions coming in, so thanks so much for participating, guys. I got one question from Sam Lucido, who asks, some arrays are marketed as, quote, engineered for flash, but use traditional RAID. What are some of your thoughts? Who wants to take that one?
I will. This is Devin. The first thing that I look at this from the standpoint of utilization of flash, of course, is that I've always kind of held it that if you place a RAID set over the top of SSD, you're doing it for the reason of data protection, because you still have to take into account potential for infant mortality, or basically a vendor defect in the flash drive that you're using. So you can't just hang it out there and expect that the stuff's gonna survive forever. But that said, our implementation was obviously to move away from using storage as an endpoint. And I think that if you're looking at restful data or data residency on flash, you have to really pay close attention to the data protective methodologies, not just the data reduction technologies. The placement of data matters, but also how do you account for failed drive? And obviously a lot of folks have looked at this from mirroring or RAID set, and yet what you're doing typically is blowing parity bits across that bank of drives. And of course, you're exacerbating the problem you're trying to prevent. Ultimately, any small page write that fractures the read-delete barrier between two pages is going to cause write amplification. So when we looked at this in early study, we couldn't figure out a way at the time, 5 years ago, that we could use flash in a way where we could put a RAID set over it and not actually cause write amplification, as opposed to eliminating a problem of data protection. So our theory on this and our philosophy of use is primarily to move away from that entirely and use flash only for caching.
So I would add a perspective, which is I believe just about every disk array is available with an all-flash option, yet you've seen the industry grow with all-flash systems that were designed for flash. And what you have to ask yourself is, if industry leaders, storage vendors who lead the industry, have selected to move away from retrofitting old systems and build or acquire flash systems from the ground up, there's something that their engineering teams understand that maybe the public doesn't understand. So the summary that I would say is, think of it this way. If you move from disk to flash in any system, whether it's your laptop or your enterprise storage array, it's going to perform better. But you will not gain the optimal levels of efficiency and resiliency if you're treating flash like disk. We covered some of that a moment ago, so I don't want to rehash that. But what I would say to you is understand that enterprise storage systems leverage their data services based on the response times and the latencies that are in disk. We don't even just see that in data services. We see this in interconnects, like SAS interconnects, which are designed to run the latencies of disk. When you move to an all-solid-state architecture, you don't have those latencies. So flash will accelerate the performance, but if you move to memory-based architectures with smaller latencies, you have to address your architecture differently so that you can capitalize on the performance capabilities as well as any other forms of data services. So it does matter if the architecture is designed for flash or not.
And I guess what I would add is, in tying a couple of those questions together, it really does come down to use case, and it comes down to what you're trying to accomplish. But I think in linking a couple of things that Jeremiah said and Vaughn said, this really isn't about flash. It's about architecting a system that can best leverage the current storage medium to do things in memory like deduplication and compression and those types of options which enable flash to accelerate. It's all about that memory and the process in front of it, not necessarily flash. So it might sound weird, but it's really not about flash when you're all said and done.
Right, and I think where the flash does still come into play is going to be during failure modes, right? So the other thing that you have to account for on the RAID side is that when a drive fails, or when the SAS connector to the drive fails, or whatever happens that makes that drive go offline, there's a process by which that data is reprotected or recovered or redirected somewhere that the customer can continue to use it, and that redundancy can be rebuilt. And there's a cost for that. There's a cost in the amount of time it takes to do that. There's a cost in the amount of write amplification that exists during that restriping and reparity process. And at some point, it just comes down to is the cost of that protection, the amount of time, the amount of resources, the amount of rights that it takes to do it, worth what the customer has chosen from a platform standpoint. What we're seeing, and I think to Vaughn's point, is that most of the storage vendors that started with a hey, let's use a traditional array architecture and just replace the disk types, have quickly realized that it just gets really expensive. It gets really expensive for them and for their customers. And so as we start to move away from the traditional array model, I think we'll start to see more alternatives to RAID from a protection standpoint. Not because one is better than the other, but it just takes better advantage of the capabilities that the flash gives us.
Yeah, I think flash has allowed the industry to have an opportunity to reimagine storage, if you will. It's not about whether the arrays were capable or not. It was, how do we allow customers to scale in a more economic model, one that's less disruptive to their operations, one that better aligns to today's IT model, which is much more, say, service-centric. I think all four of us represent products within our portfolio that are designed to do that, which is an advancement over the traditional architectures.
Applications matter, that's for sure.
Okay, we've got another one from Anthony Michael. And he asks, are you able to install flash storage in older servers? Jeremiah, do you want to take first crack at that one?
In older servers or in existing arrays, I guess would be the question. So from a SolidFire standpoint, our arrays have been and will always be flash only. In my history as part of the industry, yeah, it's just a disk form factor, right? So there are lots of different ways to be able to use that, whether it's as a cache, whether it's as a tier, whether it's as a primary storage medium. I would say that probably most of the traditional storage array vendors that the Spiceheads would be using, I'll almost promise them that there's a flash option of some sort available to them. That's part of where that form factor comes in handy. Is as long as the storage software can handle it, swapping out the drives is usually pretty straightforward.
Okay, and we've got one from Dude McGee, who has, so how does token ring fit into this picture? Sam, do you want to address that?
That's where I knew the question was coming. It always does.
I think we have a preference as a group for token ring over Ethernet, but that's probably better for another webcast.
Yep.
Yeah. We're going to take that up sometime, Justin.
I was going to say, we need a Cisco guy on the line to address that one.
And I've got one from Daryl Slay. Flash myth question: is there any software activity that causes flash memory life to be shortened?
Ooh, that's a great question. I'd like to take that one. So kind of repeating the question, is there any software out there that can shorten the lifespan of Flash? I think in part nobody intends to do this, but there are things that have some anecdotal evidence to reflect sort of unintended consequences. One of the things that we've observed in the space when we go out there and we talk to our customers, many of whom are Spiceheads, in fact, are that folks are looking for methodology for data protection in and beyond what they're doing today for traditional backup. And in the data protection space, we do see some habitual functions of using backup softwares against new and emerging storage technologies in such a way that as a workload is really a negative. In other words, if I'm streaming backup data from backup software to something, and ultimately in more intelligent designs, you can avoid sequential payloads dropping into Flash. But if you don't, there obviously is some potential, again, for write amplification, for degradation of the Flash and accelerating that. The other thing that we've seen is that write block alignment really has a lot to do with the longevity of a storage resource overall, and not specific to Flash, but including Flash. Write block alignment has a lot to do in the virtualization space with potential degradation of performance, as well as potentially the lifespan of those assets. So there are certainly things that are out there, and there's some good papers to talk about that, so I won't go on at length in detail. But it's a very important question that if you're not considering looking at what your application stack is and how they will use these brand new and emerging technology resources, you really should turn that leaf over.
Hey, Don, have you done any sort of sessions on write alignment ever, maybe?
Was that for me?
Yeah. I was going to say, I think I've seen you on stage at least half a dozen times talking about write alignment from a storage perspective.
Well, and I think, so I can't think of any application that specifically leads to the amplification and accelerated aging of the Flash cells from our side. But that's not for me to speak to everyone in the industry. I think Devin made a really good point, which is your architectures are going to dictate how Flash is addressed. And so if you've got a fixed block size back end, which is something that I was very familiar with my history prior to Pure Storage, things like misaligned I/O will absolutely increase your I/O and thus have a detriment on your Flash. Pure Storage, we've got an adaptive block size, and sorry for the company name and product plug there. I'm going to get booed off the stage for that, but like others on the stage, your systems are going to have design elements. You need to ask your vendor about these design elements so that they can help educate you in your selection criteria.
The right architecture, the right in-memory services, it shouldn't be an issue at all. So ask those questions.
Okay, and I wanted to next pull from the community post, and this is our first winner of the swag pack, and it comes from Ross42. Ross42 is our first winner, and the question is, or the myth is, SSDs don't need to be defragmented. Anyone have any thoughts on that?
I agree.
That's true? The fact is true.
Why do you defrag? You defrag to help sequential and random access and rotational delays. You don't have any of this. You think about it completely differently.
Another myth.
Hey Justin, I don't want to discount this question because it comes up a lot in the end user space, and I pay a lot of respect to this question because ultimately for Spiceheads and storage guys and storage people that have been around for a long time, there are some hygienics that are applied to the storage array that don't necessarily apply in the flash space, but there's something that folks want to understand. So realistically, there is no methodology or need for defragmentation because typically there isn't an accumulation of fragmentation in a storage array. However, what is really kind of changed in the technology of storage is that instead what you're suffering is more of a loss of localization of data. And that loss of localization oftentimes has more to do with access of data against spinning disk media, but it's something that can impact flash as well. So you really want to make sure that the data is contiguous if possible. You want to make sure that nothing is imparting a lot of change. And of course, that's going to be, I see Vaughn shaking his head, that's going to be based on the technology utilization and how the controller lays the data down in the first place. And I'm speaking in terms of loss of localization from the standpoint of individual placements of flash or flash within the server, not so much in the storage array at all.
Yeah, so I agree with Devin in the element of localization does impact disk drives because disk drives tend to have their best performance when they're doing sequential reads, and so disk defragmentation allows you to sequentially relay out your data after the data set is aged. So 2 points. The first one is I wouldn't say that defragmentation has no value if you have an application that is writing copious amounts of very small size data, 512 byte files, 1K byte files, and you're creating thousands per hour. We've seen guest file systems start to have trouble with that workload. This has nothing to do with the underlying storage. So the guest needs to run a defrag so that it can be better optimized inside of the operating system itself to address this data. On a storage array that is going to be inline dedupe, you can defrag all you want. The storage controller is not going to, the all-flash storage controller is not going to move the data 1 iota, but the guest OS is going to have a better understanding of the data and how it's going to access it. From a locality on SSD, look, reads on SSDs are literally free. Most all-flash architectures don't have a read cache like you have with a disk architecture. They tend to have metadata that sits in memory state, and all access comes right off of SSDs. Whether it's contiguous or scattershot, you're not going to be able to measure the performance delta.
Cool. Really quick, I wanted to check in. We've got some good comments coming in from the Twitter feed, and I got one from Amy Lewis who says, "Is Jeramiah Dooley playing a Flash Mythbusters drinking game? Do you drink a Diet Mountain Dew every time someone says something?" So Jeremiah, are you playing a drinking game?
If drinking games with Diet Mountain Dew are my favorite drinking games,
Diet Mountain Dew.
It doesn't even matter what the game is, I'm in.
I think Jeremiah wins that second prize pack. Was it the yoga mat? I think that's what it was for being the most underdressed.
Nice.
You can use it for a yoga mat, the expensive yoga mat, but okay, well, cool. Let's go into some more questions from the audience. Keep them coming in, guys. This is we've got a lot of good questions so far. So I've got one from Nathaniel Fagundo who asks, "How is Flash changing the way that people architect their SANs?"
Oh, good question.
Vaughn,
So here's actually a good one. Let me jump in with that one real quick because I think there's another one in there, another question that was talking about since all flash arrays tend to write across all of the disks in the array, how does that change how operational teams think about LUNs? And I think that those two questions kind of go together. It's interesting because when I look back at what I've done in storage for the last however many years, we have all of these constructs that are made up in our heads about how we put things together, right? There are disks, and then there are disk groups, and then there are extents and extractions, and we create these into LUNs, and then the LUNs roll up into the platform. And there's a lot of from my perspective, there's a lot of overhead in that, both operational overhead as well as actual disk overhead. And so one of the things that we're seeing when we talk about the differences in how customers architect their SAN, but really how customers operate their SAN, is this idea that the array is a pool. And everything that you do in that array, whether that's add more capacity to it, or whether that's provision a volume that gets presented out to a VMware environment or an OpenStack environment or directly to a server, that those things will be spread across all of the storage equally, which eliminates so much stuff from a customer operational standpoint, but also from a technology standpoint, it means that we don't have to build in a bunch of those objects that we have to manage and a bunch of those things that customers have to put together. So I think that from an all-flash perspective, we have some benefits in latency, we have some benefits in the performance in the backplane that allow us to do some things that we didn't have the ability to do on the spinning disk side. And I think that the LUN layouts and how that works, and then how the architecture of the SAN changes are two things that are tied together pretty well.
Yeah, I really like this question, and I appreciate very much the operational aspects of the discussion, given that a lot of folks really do kind of hang up on just the concepts of performance and longevity of Flash. And while those are very exciting and interesting, and I think draw a lot of people in to investigate Flash, what's more interesting to me, being a SAN architect for a long time, is really the operational aspects become a heck of a lot simpler. I mean, when you're looking at a storage architecture that allows you to provision instantaneously as opposed to, wait for a LUN creation or wait for a meta LUN creation, and that wasn't a shot at you, Sam, but the concept is that, straight away, we have a storage pool kind of design, and it is assumed that everything is going to be thin provisioned. And I like that model a lot because obviously there are some things that you can do to get yourself into trouble, but there are a lot of new checks and balances in more current SAN design, more current SAN architecture that really prevent you from kind of making some of the early bonehead moves and writing a check that the storage array can't cache per se. But operationally, you're talking about technologies that provide not only performance capability, but the ability to stand up an environment at will. So in rapid provisioning and in heavy virtual desktop environments, when you've got to spin stuff up from nothing and do so very quickly, it's much more feasible that a single person can do what might have taken a team of people to do before, and/or that single person has a lot more time to do more creative things.
So this was a really good question, Justin, and give a shout out to the person who asked it, because they deserve a lot of credit. I agree with what Jeremiah and what Devin said. I'm going to add to this conversation a couple of elements of color, if you will. I think probably everyone on this webinar understands that Flash is highly performant. I think if you're looking at Flash solely to solve a performance challenge, you have a micro focus and you are missing the forest for the trees. If you can acquire an all-flash storage architecture for the price point of disk, and that's a reality offered to you by all the vendors here on this webinar and others within the industry, you have then a design choice difference between, am I buying a legacy architecture or am I buying a solid state architecture? When I buy solid state, the first thing that I gain is a true infrastructure foundation for software-defined service levels of my storage device. I am no longer constrained by the restrictions or limitations of the hardware architecture, the different tiers, the different throughput, the rotational speed, the seek time, the access, the amount of cache. Am I more cache-centric towards a read or towards a write? It's solid state. It's going to be sub-millisecond response in terms of latency to no matter what the application need is. So that's one. It's defining services in software and having the means to just dynamically adjust those over time. Two, you're going to see other benefits within your infrastructure from all flash. Because it's sub 1 millisecond latency, every application becomes more responsive. This means all of your end users, whether they're doing big data queries, whether they're just accessing their virtual desktop infrastructure, they become more satisfied by the change. I think all of us see this when you work with a customer and they deploy Flash, that once you do a POC, the end users don't want to go back. They say, I don't know what you did. New CPUs, new software, I don't know, but everything runs better. That's two. Third is you have downstream benefits from all flash. So for example, if you have a virtual infrastructure and you are replicating for disaster recovery or you're replicating offsite for backup, when you have events that try to load balance the system, like storage, DRS, and VMware, that process ends up requiring more data to be replicated day in and day out because data locality is changing. When you move to all flash, there's no trigger for data locality changes or significant reduction of those triggers because you don't hit the latency tiers like 15 milliseconds to trigger such events. When everything's sub 1 millisecond, there's just a lot less tuning and maintenance to keep everything running, and thus you free up not just employee time, bandwidth for replication, you get greater success for the apps that you deploy, etc. So sorry for the sales pitch here, but this is where the real excitement and the rubber kind of meets the road. You solve a lot of operational problems by just moving to a faster medium, and the key to that was making it affordable.
So to extend on that a little bit, I absolutely agree that there are some applications where flash is absolutely a no-brainer. Some of the challenges come from continuing that sub-millisecond response time at scale and continually. But I'll also add that there are still applications where, with the right orchestration layer, you have the ability to deploy applications in enterprise environments and all additional and at lower cost for so flat is cheaper than but you'll and then
I think we're getting some audio problems with you. Can you? I think we're getting some audio problems. Can you try that again? I think we're not able to hear you. Okay, well, let's go on to the next question. I wanted to announce the next winner for the next flag pack. The next winner question comes from E. Chapman 930, and the question is: flash drives can be affected by solar storms and other forms of radiation, such as X-rays. For example, bit flips, data corruption, or even complete erasure of flash data.
Sweet.
What do you guys think about that?
Your spinning disk media can be interrupted by you simply yelling in front of your storage array. Check it out on YouTube.
Seen it, done it. So this is, I'll jump on this one. So this is kind of fun because I'm sort of a space weather geek too. So I actually track this stuff. So for Spice Heads, I think there's some space weather geeks out there like me. On the 17th, we actually had a pretty massive CME that hit the Earth, and there was actually a pretty significant plasma injection inside atmosphere. Not a single SSD failed. How about that? The reality is, when you look at modern technology, the shielding that is in the standard SFC or the standard package for most SSD, and I'm talking about that physical form factor of a drive per se versus a flash itself, you're talking about essentially a naturally occurring Faraday cage that's going to protect against a vast majority of things that you might be concerned about. Why I appreciate the question is that we do service a number of customers in the federal space that look at that stuff very seriously, and they have to ask those questions because they have to face those potential challenges. So when we look at architecture, of course, you have to factor in survivability of a storage array. So when we take that perspective of the entire array itself, you look at a number of different things. Part of that is the utilization of flash and what potential risk does flash impose if it were to fail. Now, obviously, our architecture uses flash as a read caching area. It's never a storage endpoint, so if all the flash is gone, there is no data integrity issue. To Vaughn's point, that doesn't necessarily mean that the spinning disks survived in that converged infrastructure. We hope that they did. But ultimately, it really is up to the use case and kind of on a case-by-case basis. We have yet to see anything that would influence the health of SSD as it pertains to a naturally occurring environmental phenomenon outside of lightning strike and being submerged in water. But we do look at this stuff very carefully because in the federal space and in government utilization, you have to take those factors into account.
Okay, let's go back to the audience. We've got a question from Robert Smith. That's a ton of questions. I'll just pick one. And he asked, per industry analyst, average flash array capacity hovers at around 40 terabytes through 2017. Do you guys agree, or will the average flash capacity increase greatly over the next few years?
So, when we look at this, our philosophy of use is adaptive flash. And of course, the flash is when we say adaptive, essentially used as a caching area, and so we can vary that for sake of performance increase in the read space significantly. For the sake of performance in the write space, of course, that's a modification of the number of CPU cores we've employed. So very different resource gain sets. But ultimately, we're seeing trends outwards of hundreds of terabytes of flash utilization coming into the end of this year and into next year. At present, we'll scale to a cache space well in excess of about 160 terabytes before any data optimization. So realistically, you're talking potentially about 300 terabytes in a fully realized cluster, without naming specific products. Thank you. But ultimately, what we see is that the trend is towards utilization of flash specific to workloads that warrant it. And so one of the things that we've really taken to heart is the importance of corrective sizing. So when you're looking at the sizing of flash for the purposes of caching, we knew very early on in architecture that if you had a flash area that was approximately 10% the size of the disk storage capacity that you were putting out there, you could float better than 90% of the reads from caching area. Modern day workloads now, 5 years later, that isn't necessarily true. You would see workloads that are thrashing in excess of 50, even 80% of their data. So in a caching vehicle, you need much larger amounts of cache to be able to sustain those workloads. However, we drive ever towards efficiency because we do recognize flash is the most expensive resource that we're offering, and we want to be able to utilize it to the highest possible efficiency. So data organization, again, really matters in the design to reduce the amount of physical flash that you have and obviously reduce the cost associated with that.
Yeah, so I think for clarity on this conversation, I think the audience needs to understand that we're all pro-flash. Some of us represent products that have flash that uses a cache tier that's mixed with disk, and some of us promote all flash arrays. So constructs like thrashing, is not seen in an all flash architecture, right? But obviously there's challenges within that space around cost and sort of stay out of that. I just want to make sure that they understand that we're not painting the world all with this same brush. Going back to the premise that you made around capacity and growth, I think there are three interesting elements. One, yes, flash capacities are increasing. You're seeing the price per gig rapidly come down, both through increased fabrication rates as well as increases in the technology that drive the density up. So you should see an increase. I think this information is being vetted, and you'll see more of this as I think not just the vendors, but also the analysts are reassessing their forecasts for all flash adoption rates. I think the growth rates are kind of off the chart right now, and it's taking the industry by storm. I think second, I think you will see flash today in the tier 1 space. I think you'll see it in the tier 2 space rather aggressively. I'm going to put my money down, and you're going to see it the first half of next calendar year. Tier 2 or more capacity-centric flash doesn't need the performance that many of us try to talk about with flash. The capacity-optimized flash benefits from the low footprint, the low power cost, the lack of needs for heating or for cooling, I should say, this medium. It is more appropriate for the scale of data that are facing enterprises and businesses around the globe. So think of flash as being much more green, data center efficient, right? We have customers who measure their storage needs based on gigabytes per rack unit and watts per gigabyte. That will become the new metric in capacity optimized flash, and that'll be a topic for 2 years from now. Last, capacities for flash this year do have customers revisiting what their failure domains are. You can't make one pool that fits everything forever because the risk of failure would be too catastrophic. So I think your better question is what type of boundaries are customers looking to design their failure domains around? And are we going to change models with flash from what we had with disk? Right? It's pretty common in the enterprise to see, say, failure domains around 250 to 500 terabytes. Are those going to move to petabyte and 2? I don't know, but I do think flash is allowing us to revisit that conversation.
I wanted to announce the final swag pack winner, and that's Jeff11251. And the myth is, or the question, do you foresee a point in the future where flash storage will be cheaper to manufacture and purchase than traditional spinning disks? And will this be the point that sends the hard disk away as a floppy?
Good question.
Do you want to take that?
Yeah, I appreciate that. And it's a question that I think it's a conversation that we're having with our customer prospects on a daily basis. Our philosophy, again, is that with the proper utilization of the resources, you can build something that's kind of better than the sum of its parts. So obviously with our converged architecture, we're leveraging disk and flash together, to Vaughn's point earlier. And this is obviously very different in architecture than a flash-only array set. What we're watching closely is what the trends are in manufacturing and in consumer behavior, that if we see that flash makes sense as a unity construct, and that flash becomes more resilient and there are different price points and different layers or different tiers of performance, it obviously is kind of the way of the future. It makes a lot more sense. At the same time, what we do anticipate is that there will always be some kind of construct that is faster and more expensive, i.e. potentially, let's say, MRAM down the road, versus something that becomes higher density and less costly. Well, perhaps that's SSD moving into that slot, and maybe that does eventually obsolete disk. But just in the days that I was at Data Domain for a long time, and of course the notion was tapes going away. People are still backing up to tape. there is still a cost-effective medium discussion to have there when we're looking at 6 terabyte spindles there, and just through data organization, I can drive what is essentially between 6 and 10,000 IOP into a 7,200 RPM nearline spindle. Why would I make it go away when it costs, you know, pennies on the gigabyte by comparison to Flash, and I have performance capabilities, you know, vectoring literally in excess of the performance that we see from a Flash-only array, driving into 7,200 RPM spindles. So I think it really warrants some investigation on the utilization of disk versus Flash, because, you know, while there's a lot of connotation that Flash really is the way to unlock performance behind critical applications and very peaky or very niche workloads, that may be the case, but realistically, if you're looking at IT generalist infrastructure, you want capacity and performance and data protection in the same frame if you can get it. And that's really what we aim to be able to satisfy.
I'm going to give you a different perspective than Devin. I think the challenge that you have with all Flash systems today is the price of entry point. You probably see a lot of systems probably struggle to get below $50,000 US as an entry point. So in that small to mid-size market where, you know, maybe a sub $50,000 array is attractive, I do think there are limits to Flash going into that market today with today's product sets. I say though, once you go upstream from that, you can absolutely have all Flash at the price point of a disk array. And at that point in time, you're going from a mechanical rotating infrastructure to a solid state that in no way, shape, or form has better attributes than what all Flash has, whether it's density, power, cooling, or performance requirements. So it's not about whether the app needs the performance. It's about total cost of ownership, whether that's measured in employee time, data center resource constraints, and oh yeah, by the way, everything runs faster. I think the forward-looking statement, the one that I'm really bullish on, is Flash at the capacity tier. I don't think disk was ever designed to really be a replacement for tape, because disk, you can't power it off. It's too power consuming, too much of a power draw. It's always a caching tier, a temporary or tertiary resting area for data before it goes to its archive. I think Flash will take over that space, and it will start next year. Will it be pervasive next year? No. It large scale 2017, but the conversation and the products that will be supporting this space will be here next year. And you can just look as simply as the Flash vendors or the fabricators. You know, they're talking about 14 and 16 terabyte SSDs that are 2.5 inch size in terms of their form factor. That's greater than what's available with disk today and what's going to be available from disk tomorrow. As disk moves forward and you look into technologies like shingle drives, that's now adding a form of write and overwrite that's native within Flash, which is write micro, erase macro. Put that on a slow disk and make it exponentially slower. Folks, disk is dead. It's about when will the price point get there for your need. But I don't think anyone here is going to sit there and defend the longevity of disk.
Yeah, I think that I agree with some of those points, and I think where our opinions differ really do root in kind of who we work for and what our own futures are internally that we know of that other people don't. And to come back to my point of clarification, it's that we really architected ourselves to be able to use whatever storage medium comes along that is best practice and best price to performance and capacity in that present day. So in situ, we are leveraging disk and Flash because that works really well for us, and it provides our customer an economy of scale and capacity density that they seem to be pretty ecstatic about. What we anticipate is that tomorrow, Flash does become that more commodity storage density tier with a great deal of resiliency embedded in it, and as that technology matures, it becomes much more interesting. The question that we have is, what is the next thing that takes up that upper performance tier that we can leverage for that caching area, whereas today that's Flash, tomorrow what could it be? But ultimately, we wanted to eliminate any potential dependency on that sub-architecture, and that's really where we've gotten away from that. With Castle, we really don't care what's underneath Castle. It's a matter of figuring out that there's probably going to be something that's higher density and cheaper, and something that is more expensive and a lot faster, and using those things to the best benefit is really our aim.
Well, really quick, I did want to announce the winners. So again, the winners of the swag bundles, we've been taking their questions earlier. It's Ross42, E. Chapman 930, and Jeff 11251. And to announce the winner of the $50 Amazon gift card, the winner is Robert May from Lakeview, Minnesota. And the winner of the Lenovo tablet is Ian Overholt from Columbus, Ohio. So congratulations to all you guys. If you guys want to PM me in the community, or you can email me at justino@spiceworks.com. We're going to put the email and the community profile link into the chat below. Devin, do you have any kind of final thoughts for everyone? Anything that you want people to check out?
Yeah, I really appreciate that we had a forum to address some of the myths that are out there, and there are many more that we didn't get to today. I think it's important that everybody does the research, and realistically, what I implore everybody to do is focus on themselves. If you're working within an enterprise environment, recognize that you're a steward of that environment. You're a steward of the technology that's in use. There are a lot of choices out there, and it's a very interesting time to be looking at data storage and compute specifically, because the resources are very exciting. There's a lot of new things coming out. There's a lot of change occurring. It really pays dividends to do the homework and understand what's out there. There, we got some background chatter. It really makes a lot of sense to do the homework and understand what's out there and ask questions. Every single one of us is more than happy to take up conversations on Twitter and funnel those into background conversations offline anytime. We really do excel at characterizing the information flow into productization. So your input very much matters into what comes next and what kinds of things you want to see. So this is just one small form step that gives you that audience voice, that we can hear that and understand what's important to folks. Speak up. Don't work in a vacuum. It really makes a difference in the future of what you're using in your field.
And to that point, we had a ton of questions and myths that we didn't get to, but rest assured we're going to have these gentlemen reach out to you guys after the fact to make sure that they get those questions answered. So, Vaughn, do you have any kind of parting thoughts for anyone?
Yeah, first off, I want to thank all the panelists for their participation and all the attendees. We will dig through your questions and respond to them. Hey, this is a conversation that's going to continue on. So make sure that you're hitting all of us up on Twitter. You guys have seen our Twitter IDs. Stop by and read our blogs. I'm putting more out on virtualstorageguy.com, and I just want to compensate here and share with you. Jeremiah and I have been talking about working on some joint blog posts to help kind of debunk some of these myths. So you can look for this on our respective blogs. It'll be the same content. We'll get that out over the course of the next couple weeks.
So again, thanks to all of the panelists for joining. We're out of time now. Devin, Vaughn, Jeremiah, and Sam, thank you guys so much. Thank you so much to Nimble Storage, Pure Storage, EMC, and SolidFire for being part of this. And thanks to everyone who showed up today. Thanks for asking such great questions. We hope to have a lot more of this type in the future. This group especially was a lot of fun to work with, so we're hoping to get some more events about this topic again. So until next time, we hope you guys will join us again, and stay spicy, and we'll see you guys next time. Bye, everyone.
Thanks, Justin.
Cheers. Thank you.
Thanks, everybody.